Alright, trying something new, kind of a presentation style video instead of the usual talk stuff. Well, me talking stuff. Just this here kind of writing that you can keep reading and see if it sinks in and stuff like that there. So just an overview, don't know where I'll end up exactly. Just going to experiment a little with I can draw and I can change the graphics, you see. And okay, so the beginning is all right. Conventional physics. This really started 100 years ago. Um, I had decisions to make about how to think about how the universe is constructed, and there was this concept of frequency or wave-like, the idea of it, and the idea of particles, and whether you could um, break the physics down into some kind of atom, something, some fundament particle. And that sort of led to another, 50-50 kind of pick between an idea of an ether or a medium that the entire universe existed in, and that forces and stuff like that were waves or vibrations through the medium. That's pretty much all the Tesla people and such. They basically, even maybe even Piro, think of photons and gravity and magnetism as forces that are somehow vibrating or moving through some momentum mechanism, some sort of constituent ether. And this sort of bends into Einstein's bent space, which basically sounds like an ether. It doesn't sound like empty space. If it's something you can bend and it's not a space in the traditional sense of a vast nothing, it's clearly a something. And so these are the questions physics had to deal with. About 300 years ago, a French guy did think of the idea of thinking about gravity in terms of it being particles. Ultra mundane is how he is quoted as uh, describing them, and that these little particles, most of them would travel through things, but they would, get stuck in things and propel them towards each other. And this created the idea of a shadow gravity, where if you had a dense random field, you could place two objects in it, and from both perspectives there would always be things converging on them, like the opposite of a light bulb. There would be little elements that would constantly hit them, and if they were in proximity to each other, they would essentially shadow each other from the ones on the parallel to their association. So if there was one object here and one object here, then the force coming this way would be the force blocked between them, and there would be a low pressure and they would be moved towards each other. The debunk of that was that things move through space without any friction, and so the idea is that as you move faster and faster, you'd hit more and more of these particles. Um, Now it's sort of a trivial reason, in my opinion, to discount something that fits in all other ways. So that gets to this idea if you understand what the forces are doing. So let me go to these talking points. So there's three forces: gravity, magnetism, and you could think of magnetism as fitting into the category of the strong and weak nuclear forces. They have to do with the forces that really have to do with the association between electrons and protons and the effect that photons have on those. But let's just say, for the sake of argument, there's three basic forces. There's gravity, there's magnetism, and then there's the spectrum we consider to be the photons or light, things at a frequency. And that would go from radio waves to cosmic type photons. And all of these forces, something that should have said something to somebody somewhere, is that all the forces travel at the same speed, and they follow the same rules of anything traveling in straight lines, which is they diverge at a fixed rate, which is the inverse square rule in most cases. If you have an infinite plane, if I could make a flat surface that was infinite in terms of its width and length, breadth, and no matter then what force I irradiated from that, whether it was gravity or magnetism or light, it would have no degrade. So no matter how far away I moved away from it, the force would still be just as strong at the surface as it would at any height above the surface. And these are rules that all these things obey. And the only thing that diminishes their capacity to affect something is the fact that they do diverge. And they diverge kind of like the peacock feathers in a 180 degree from the relevant source, like gravity. Two objects gravitationally affecting each other are essentially accelerating towards each other, and what they're doing is absorbing force in this plane. So it's only in this half of the circle, so to speak, do they radiate force. And it's the fact that they're radiating it all these directions. So one thing's coming at it this way, and it radiates force in all directions. So the gravity over here, and the gravity here, and the gravity here, and the gravity here is all the same, and it's all being caused by that one object. So the object's here, but the gravity scatters in all these directions. So it's not like a laser beam. Instead, the positive force, the reaction force, goes out in all directions. That's why gravity diminishes by the r squared rule. And it's the same rule for all these other things. The catch is that the light, we are able to make laser beams and other manifestations of photons. That breaks the inverse square law in the sense that unlike a light bulb, a laser beam at 50 feet will be pretty much just as strong as it is at 5 feet. Because there's a lot less divergence, a lot less spreading of the energy. Alright, but this was a real giveaway. The fact that they all have the same speed. And so now we call it the speed of light. And if I were to suggest that if I was to change one word in history, if I changed that concept of the speed of light and changed it to the speed of force, I think people would understand how related all these mechanisms are and how easily they are to unify, in the sense that we see something right there. They all have in common. The force moves in straight lines, and the force moves at the same speed. And so we think of the force, this electron force is what I'll call it, because the key thing here is what gets affected by these forces. Gravity affects both electrons and protons, but it's a mixed force. So essentially the force is quanta. If we called them tons, we could call them quantons, and just say that they're just this stuff like this, except they come in two forms. We could say blue and red or black and white, it just doesn't matter. And gravity is a mixture, so it has both blue and red polarization in mixed proportions, randomized. Magnetism would be concentrated polarization. So the for example, I could put this diagram here for now. The one side of the magnet is irradiating all one kind of quanta, and the other side is radiating the opposite quanta. And no matter what energy comes in, the gravity, the field energy, it comes out from the top in the red form, or in the bottom from the black or blue form. So it's polarized quanta. And light is a mixture of it's basically polarized, but it's at a fixed frequency. So it can have one red and then three blues and then one red, but the reds always come at the same timing interval, and that's what creates a photon. So a traditional, when somebody says photon, it's really not, it's not really one thing, it's really two things at least. Maybe 3, maybe 5, depending on the energy of the photon in the sense of how much time and how many quantons are in it. But it's at least 2 of the same polarization at a fixed distance would be the definition of a photon. And to use an example why photons are so, they only affect electrons, they only tip electrons, so to speak, and induce acceleration in electrons. And they do it by hitting them at an interval the electron is sensitive to. So depending on the configuration of the atom and the configuration of the electrons, how tightly packed they are, they will or will not be able to absorb a certain frequency or pulse of light. But you can think of it as if you wanted to knock a building over that was capable of being tipped. It was wiggling. It was wiggly. If you hit it, you know that if with one rock you can tilt it and then it'll rock back and rock back and rock back. But if you hit it and you hit it again right when it's at its lowest tipping point, you can knock it over. And the same kind of effect is with electrons. They have a tipping point, so to speak, where a certain minimum amount of energy will allow them to accelerate if you hit them twice in the same direction at just the right frequency. You will be able to give them acceleration with a minimum amount of energy in terms of the photon. That's why photons seem powerful. It's because they have the ability to manipulate electrons, especially in the visible light spectrum. Alright, I don't know if I have to go into a huge amount of detail, but the idea would be is that photons are made of the electron force. So if we call the electron force blue and proton force red, that would be the plus and minus electrical forces. The frequency of lights, the light spectrum, is only in the electron spectrum, so it's only in the blue spectrum. So you'd only have frequencies that are of red wouldn't affect an electron. Magnetism I've already covered, and gravity is the mixed polarization, which means it has a mixed effect on electrons and protons, and that the red elements of the gravity will affect the proton, the blue elements will affect the electron in terms of giving them acceleration or creating inertia, which is all of these things affect the idea of inertia. Inertia is the movement of matter by these forces, and these are the only forces that do move matter, because they change the configuration, the internal structure of electrons and protons. So when you gain acceleration or velocity, it's because your electrons have changed their shape and have more component going in the direction of your movement, and they've absorbed that component through one of these forces being added to them. They've collected the acceleration, just as you collect acceleration towards the Earth from the force of gravity. So now, going back to the particle gravity theory that was debunked or dismissed rather casually just because of a little bit of a heat problem, essentially. And that heat problem is fixed if you understand this mechanism as a kinetic mechanism, because they're all moving the same speed, they all have the same size, and they all have the same momentum, and there's no such thing as a half of one of these quanta. They're whole, and they always move the same speed, and they interact with each other purely kinetically. So it probably is worth a drawing, so I can attempt to draw here. Missing from this drawing is just the head-on collision. I wanted to point out that when you have a head-on collision in a kinetic field, it's indistinguishable in terms of the result you get from a non-interaction. So you can sort of think of it as this arrow bounces off this arrow and this arrow bounces off this arrow, and they go in opposite directions, or you can think of it as them just going straight through each other as if nothing happened. That's why there's no friction in moving through the field, is because essentially it's always an invisible interaction. A head-on collision is the least of collisions. The collisions that are important in physics are the perpendicular interactions, as I'll demonstrate with these two. You probably can't see them too well, but these are arrows going in, and what you can see here is that depending on how you look at it, things can stay the same, or they can change rather radically. And in a sense, if you understand a red going in and hitting a black, and then the reflection would be the red going off this direction and the black continuing this way. So in this sense, this is clearly a different universe where there's a reflection. So the reflection means that now what was red is now black, and what was black is now red. So the universe has changed. Where in this interaction, nothing changes. It's as if they didn't have an interaction. So in a sense, what's happening when something's moving through the field, or it has matter, when it gains velocity, is what's happening is you can just think of it as getting thinner in the direction that it's moving. So as it gains acceleration, what it's doing is it's adding little bits going in this direction, the direction of the movement, and it's losing bits that are going this way. So if you thought of, if I were to draw what I would speculate something like an electron or a proton would look like, they're just basically vectors of force. And the force is kept and contained by this external pressure that's constantly applied by this random force. So this external pressure comes in and reflects these bits back into each other. So all these stay blue because the force keeps bouncing them into this circle because the pressure is sort of even. So an electron sort of gives you an example of what the blue force maximum pressure is. And a proton is likewise the representation of the density of the red arrows, well, I mean the blue arrows. It's inverse for the two. The red force contains the blue force contains the red. So they're inversely related. So the force is proportional to the opposite thing's consumption of force, so to speak. But anyway, I didn't draw these in red, and I should have, just for illustration, because that makes the illustration a little better. But you can imagine there's both red and blue coming in, but the blue will tend to accelerate the object. But you can understand if a blue comes in this way and accelerates this way, and then another blue hits this way, it'll accelerate back the other way. So as long as the force is balanced, the entity will stay where it is. But you can sort of see how the force can contain this if it's constantly reflecting. So these are all reflections. Every time a quanta hits a quanta, it reflects. And the only question is, well, there's no real question, it reflects. So the color going in ends up being color going out, and vice versa. So that's how the universe changes in those interactions. But as a force, it's the same. Doesn't matter whether blue or a red hits, in a sense the same. Either force will be expelled, or force will be absorbed. And so when it's absorbed in matter, the point is that there's still a conservation. So if this gets more blue force, let's say, behind it, it has to be blue and red to move real matter, in the sense that the protons also have to be moved eventually. But just for the sake of argument, if this was an electron and it absorbs some blue and in this direction, so now the electron is moving, what it's going to do is it's going to get rid of the ones going the wrong way. So matter essentially gets thinner as it moves faster. The atomic structure gets thinner, and that means there's as these things going back and I didn't want to get into this detail, but as these things are going back and forth with each other, they're essentially interacting with the perpendiculars all the time. So they're constantly hitting each other in that center and reflecting. So now they're constantly changing directions. And so any force that any extra you have in this direction is going to get equalized, because it's going to get rid of stuff going in this direction, or up and down, of course. There's 3 dimensions only. No such thing as a time dimension. All right, I don't know if I wanted to go into. I wanted to stick basically to these principles. Um, I mean, and just get to the overview of the contrast to what conventional physics has done. So, just again, by recognizing this simple truth that these forces all move the same speed, they all function the same way, and they have the same conservation rules, and they have the same rules of divergence, which is the R squared rule. And depending on their configuration, like I said, in a wire, when electrons are moving in a wire, the rule is a little different just because the radiation falls off at R cubed. It falls off much faster because it's not being produced in these two. It's only being produced in one dimension, and so it weakens quicker as you get further away from it. It's not a pure. It's not a complete. It doesn't go in two dimensions. It only goes in one dimension. So therefore, it's the cubed amount of degrade. And again, as if there was an infinite plane that produced the force, then it would be 1 over 1, or 1. It wouldn't be. There's no R to. There's no inverse square rule. There's no loss of intensity. And like I said, those rules apply to all of these forces. So as history went, so they first kind of decided not to accept a particle theory of either magnetism or gravity because they couldn't see it, they couldn't recognize it, and we could see photons, so that made us think photons were different than these other two forces, even though they had the same speed and obeyed the same straight line divergent rules. And I'd say that was a fundamental error, in just a pretty obvious place where they should have investigated tying these things together as particles from the very beginning. So obviously the one that's at frequency is the one that's going to be the most wave-like, and it is. There's very little waveness to gravity. Magnetism, very little waveness unless it's electromagnetism and you're creating an alternating current to transfer current into another object. And I can explain that simple process. That's just really the evacuation of current from the... When you have an electromagnet, it basically is just pushing the electrons out, and it has to switch or reverse to allow the electrons back in again. It can't keep pushing something when there's nothing left to push. So that's why the current has to keep switching, is it has to push back the electrons it pushed out. If you had a constant current, it's basically an evacuation of all the electrons, and they would just stay evacuated. It wouldn't be able to move any electrons once it had moved them the first time. Well, I just gave you some explanation. I wasn't going to do that. But anyway, so historically, they like I said, they did have. So this is about Maxwell's time, when Maxwell was basically the guy who created the idea of an electromagnetic spectrum that they put photons into, even though there's no evidence that photons have any magnetic or electric qualities. They can't be moved by magnetism. They can't be affected by electricity. It's not relevant to their existence, and it's only relevant when they are inside of an electron, so to speak. When a photon accelerates an electron, the electron can move, and then the electron can readmit the photon. And that's the only time you see photons being altered in their straight line force, is when they hit an electron and the straight line is a new vector. And that's basically called diffraction, and it's basically the core of all photons that are doing anything mysterious. Photons are essentially like these gravitons and magnetons. These things are all just straight line little forces. They don't do anything funny, different, unless they encounter an electron or a proton. Alright, so Maxwell's equations are basically just gravitational equations applied to magnetism, and that's another giveaway. Now here you are applying the same kind of equations to another force, and on top of that, it has a little element where if you alternate the magnetic force, it does a little bit something different. So it's just, you have these connections that are just so obvious between these, and instead of recognizing that photons are a kind of magnetism and gravity, they kind of turned magnetism into a kind of photon, and created this idea of an electromagnetic spectrum for identifying photons, when really what the photon, the only thing that has an electromagnetic spectrum identity is the electron, and it's the electrons that are creating the interesting effects that photons have on the world. Clearly, electrons, when they hit electrons, will have the same effect as photons hitting electrons. They'll move them, and likewise, the anything big enough to hit an electron, or to be where an electron would be significant, like atoms, things the size of atoms can be affected by electrons hitting them, because electrons are fairly substantial from an atom's point of view. But once you get to material objects, then it gets harder and harder for electrons to have an effect. This I'll probably get into. I'll do another video on the two-slit experiment and go into some greater detail about that relationship. But that's essentially the relationship creating the effect in the two-slit experiment, is just the fact that photons are of the same polarization, have the same polarization as electrons, and they are they're having their destiny changed by their interaction with the electron. And another key point here is in magnetism. It's a kind of a known fact, electromagnetism especially, that as a body gains this acceleration or velocity in a direction, as it's gaining it, as it gets acceleration, it loses this stuff from the sides. Well, it's not insignificant that when electrons are accelerated, they give off what's called EMF, or electromagnetic radiation force, and that force is what's conveyed into another wire to create magnetism and what we call electrical current. So it's an increase in, I think I dropped a pen or something here, but I don't know where it went. Alright, time out. Must have fallen somewhere I can't see. Somewhere the computer. Cool. See if I can unplug something. Alright. Yeah, so Maxwell just reinforced a mistake made, and then we got to, the early 20th century, and then the invention of quantum mechanics. First it was called quantum electrodynamics, because it had to do with this relationship between photons and electrons. And then the two-slit experiment, and Einstein's relativity and bent space. People were just, somehow they got all confused, and they started turning photons into nothing like a particle, essentially entirely a wave packet or something controlled its movement. And they would concede it was they would concede it as a hard body, something that couldn't be cut in half, and something that always landed at a tiny speck. And so they would concede its particle nature, but they gave it all of its navigation over to some other kind of force carrier, and not really recognizing that photons are force. They can't be affected by a force carrier. They are a force carrier. Photons move force from one place to another, just like magnetism and gravity. And that was a huge mistake. So you can sort of see, like, Einstein's bent space is just a mischaracterization of this particle gravity, and essentially it's called the Mach gravity. If you look that up, it fits the entire model of gravity. It has everything gravity needs to have. It follows every mathematical requirement to duplicate or model gravity perfectly. And again, the only thing it lacks is that it has this deficit of where it would create friction in an ether. But as pointed out, there is no friction in a kinetic universe where everything's moving the same speed. So technically, when your matter has, when you have velocity, that velocity isn't really you. It isn't real. It's just made out of these little bits moving the speed of light. All movement is at the speed of light. The little bits inside of you are moving. So essentially gravity is a nuclear force. It's only moving electrons and protons and neutrons. It's not moving anything else. The little tiny bits are the things affected by gravity. The little tiny bits are what's affected by magnetism. And the little tiny bits are what's affected by light and photons. They're this. And or you can think of it as spreading a movement over a million of these. So if I have a school of fish that's staying in one place, and I add one fish going this way, you could sort of understand that that one fish, for this whole school to move this way, it has to communicate that movement to all these other fish. So you can imagine if there was a million of these little fish, it means this school will move 1,000,000 times slower than the fish that went in. So the fish going in is going the speed of light, so to speak, and the movement is going to be spread over the entire school. Each little fish will have to move one step in that direction, one step, one step, one step, and it'll take that much time, 1,000,000 planks of time, and it will reduce the speed by 1,000,000 times slower than the speed of light. So you can just kind of think about it that way, that all these arrows, except for the ones already going this way, have to be told to go this way. And that takes time, and that's why matter moves so much slower than the forces that move it. That's why it takes so much force to move matter, is that it takes a lot of fish going in to get this thing really going, any kind of speed. And if I were to get this going really, really fast, what it would really mean is that I converted all the fish going any other way but that way into a fish going that way. So for matter to go the speed of light, essentially you have to make all of its bits go the speed of light, and therefore it would have no structure. It would just be light. It would be a beam of light. So matter can't go the speed of light, because if it does, it just becomes force. It becomes a beam of magnetism, gravity, or photons. Alright, so I think we'll just switch a couple of these images and see if we got something else to say here. This was an old diagram of gravity. So the force is coming from other sides, and you end up with a low pressure, because these are being, as it gains acceleration, just as I pointed out where the fish have to communicate. So this forward movement comes in here. It has to communicate over the whole thing and to move this object. And as it's communicating, it's taking a long time. And so it doesn't come out here and hit here. So it was supposed to get here, say 20 minutes ago. It didn't get here. Therefore the force here made this start accelerating into that absence of force. So this started accelerating. And when this starts accelerating, that means this arrow is going to get absorbed for 20 minutes, moving through this to move all these little bits. And that means, and so that this thing starts moving, and then this one starts moving. So like with electromagnetism, gravity is inductive. So here's another reason to see these forces very tightly tied together. Gravity is induced in the bodies. That means the more they associate, the more gravity they create. As this one accelerates, and that they keep accelerating into each other's acceleration. And that's the same thing that happens when you induce magnetism in a conductor, electricity in a conductor through magnetism. It's all induction. One provokes a reaction by the other, which causes an action by the other, and it's a chain reaction. And so it's another reason to see a huge correlation between these forces. And here's an image of magnetism, and the idea that you have these. In this one there's a third element you don't really need. So all you have is this red, and the blues are coming in mixed form, and only reds come out of one side, only blues come out of the other side. And so when the blues hit a red, it reflects, and so that ends up accelerating the blue in well, I won't go into the, I'll save that for a conversation on protons and electrons, because it gets a little complicated. I mean, any blue will get absorbed as an arrow, but the idea is that when they're blue on blue, it's reflecting. This should be red, and so the reds get reflected back and forth between the two blues. So as they get closer and closer together, that means the reflections are happening at a higher and higher frequency. So that's another point where frequency comes into it. But again, the frequency, the idea that frequency always means wave is just a real mistake that has been made in physics. So these were some ideas of how you can create movement through an imbalance, but you don't need orbits, I don't think. So that sort of changed. But this idea of an input in, output, it's all a closed system and it's all conservative. So if you understand that the forces of gravity are always there, you know, that it's this constant field energy that is converted to create gravity, and converted to create magnetism, converted to create photons of light. There's always the same density of energy. It's just what polarization is. So if you were to pull out of this a little bit of matter, matter would be identified because all the red arrows were in one place and all the blue arrows were in another, in the sense that all the blue arrows are in electrons and all the red arrows are in protons. So it's little collections of polarization. That's the only thing that identifies matter from field energy. So here's some two slit diagrams, just pointing out the surfaces thing. So in the single slit, there's obviously no impediment in the center. Double slit, there's obviously a impediment. So obviously you would have more light going straight through. And whenever they talk about this, they never really talk about the fact that this is a tiny, tiny slit, and it's projected on a distant target. And that the truth is that any light from the slit goes straight through, hits the center. There's no, whenever they draw it, it's always drawn out of proportion, and then they're allowed to make people visualize things that aren't possible. This is a tiny, tiny slit, and it diverges not very much from a straight light beam. A straight light beam would not diverge that much going through the slit. But it's understand there's these it's really the surfaces that are the experiment. All right, here's the good diagram of the single slit pattern and the double slit. And this is the thing they don't explain with their math is these zero areas here. And so your double slit done well has a really strong pattern. Also, what hasn't been ever done to my knowledge is, it seems, depending on what you do use for your slit material, the number of bars you get before you get to these cutoff points changes. So that seems really important to my theory of this being caused by a field of electrons, is that the number of electrons would be different depending on the materials. But yeah, no one's done the as far as I know, any kind of survey, because it does seem like the number of bars varies depending on how the experiment is done. And clearly with the single slit, you can have 20 or 30 of these bars with a single slit at the right aperture using the right materials. And doing it differently, you can end up with a very dull pattern of just blob, blob, blob. And so the fact that there is such variance depending on the width of the slit is just something that's never discussed by people discussing the two-slit experiment or using it as a reference. And there's another drawing that I had done. Same idea, that you can see the double slit has the breaks in the pattern. This is the single slit, and this is what they often use to discount the single slit experiment. So these are the kind of results you can get by actually doing the experiment, and they summarize it as this boring kind of pattern when it's a very rich pattern. Alright, I guess this is the last drawing I did. It's not much different, not much better. So this would be your single slit, this would be your double slit, And like I said, if you have a very narrow opening, the pattern will look like this. Very uninteresting. A wide opening, you get a very interesting pattern. And that's the single slit, and this is the double slit pattern. And again, these breaks aren't explained by the math. And on top of that, the bar count isn't accounted for either. They don't account for the light source, so peaked light and laser light by the math creates the same pattern, which is intensity profile, which doesn't make any sense. So there's lots of problems with this analysis. In the next video I will go over some two slits, and whenever you'll see the math done for the two slit experiment, nobody ever mentions Huygens as a necessary feature, and yet they always have to use Huygens to explain the single slit pattern. So how can you have a principle that you only apply when there's one slit, but you don't apply it when there's two slits? If it's a function of physics, this Huygens principle, then you would have to apply it in both experiments. And that isn't no one's explaining why. They all do it wrong, and I'll show them doing it wrong. I'll show Yale professors doing it wrong, describing it inaccurately. It's not a conspiracy in the sense that I don't think they're doing it deliberately. I think everybody's just accepted this stuff. Einstein comes along and says bent space, relativity, that the force is lensed. There's no evidence of forces being able to be altered by forces. The original concept of superposition essentially stated that a force, forces are act, and once they act in their direction. So if there's two competing forces, the forces don't blend together. So even though the forces are smashed together, they don't really blend together. They only blend together when something's in the field, and then the thing in the field says, what is point A throwing at me? And it could be like tomatoes. And then it says, what is point B throwing at me? It could be cucumbers. And then it will decide what cucumbers mean and what tomatoes mean. But the forces themselves don't mix. That's a very strong reason. First, not the waves mix very easily, and it's also a reason, to recognize. Yes, I had a point there, but I've lost it. But anyway, getting a little tired, so I'll let it go here. And so I'll try to do this with the other subjects, inertia, and I'll go into particulars of gravity and magnetism, and protons and electrons, and the function inside of atoms, and we just keep this as documentary as possible, and then I'll do some videos citing the evidence available on the internet in terms of video presentations and lectures and documentaries, and point out where inaccuracies are stated. So anyway, thanks for watching, and until the next time and such.